So we're going to go into the chapter 12 lessons that have to do with surface area and volume. We're going to be doing all surface area together in one video. So we're going to be starting on page 94, but we're going to be skipping around in your green packet quite a bit. So just follow to which page I'm telling you to go to, because there'll be multiple pages that we look at that are all scattered. All right. As far as vocab, we are only going to look at a few words. We're going to start focusing on just surface area, and we're going to look at prisms and cylinders first. We're not going to look at any volume on this video. So the first thing I want to point out are a couple of these words that you might need as you do these formulas. So lateral faces. So what I want you to think of is a lateral face is a face that is not a base. So rather than drawing a picture, I'm just going to kind of show you what I'm talking about. So if you go down to the bottom of the page, this is called a solid. It's actually a pentagonal prism. And in that pentagonal prism, you have faces and you have bases. So when you look at for the things that are bases in a prism, you are looking for two things that are parallel and congruent. And they don't intersect each other or touch each other. So for instance, the pentagons are both considered bases. They're parallel and congruent. The faces would be the rectangles that go around the sides. So keep in mind, you've got to know the difference between bases and faces. Bases are the two polygons that are parallel and congruent, and the faces are the other ones that will usually be rectangles or parallelograms that go around the sides. So that's what a lateral face is, something that is not a base. All right, the other thing I want to point out that we're not actually going to find this year, but I need to point this out, is what the heck is a lateral area? So as you look through some of these questions, you're going to see an L, or sometimes you'll see an LA. So the lateral area is actually the sum of the areas of all the lateral faces. So if they ever ask you for a lateral area, your lats are your sides. So anybody that exercises or works out, they probably know their lats are on their sides. The lateral area of something like this figure down here would be the area of all the rectangles, but don't add the areas of the bases. Now this year we're not going to worry about that. We're just going to find the surface area. I just want you to know when you see L, that stands for the lateral area, which are the area of the faces. Okay, and then the last vocab word I want to talk about is axis. So I won't call it this most of the time, but an axis is going to be the altitude. No, that's not what I wanted. Hold on, I gotta find the right one. Oh, never mind. I'm looking at the wrong one. The axis is the segment with endpoints that are the centers of the circular bases. Okay, so this one I will sketch a little picture of. So you guys have seen a cylinder before. It's like a soup can. And so if you draw the two bases as circles, like a soup can, and you put dots in the center of both of those circles and you connect them, that sometimes is referred to as an axis, or the height of your cylinder. So I just want to point out the vocab word. If you ever hear that that's called an axis, the axis is the height of your cylinder, and it will be a segment that connects the centers of the circles. All right, so now on to surface area. So if you are online, you will need to pull up your surface area formula sheet that I attached to the module. If you are in class, then you should have yours in front of you. And we are going to go down to the bottom, and I want you to go ahead and X out lateral area. We're not going to focus on lateral area. We're only going to focus on surface area. So this is a good time to point out that in our book, if you see an S or an SA, that stands for surface area. They don't like to write it out a lot, so an S or an SA will be surface area, and an L and an LA would be lateral area if you see that. All right, so go to the next page. We're going to skip example 1 because that's on lateral area, and we're going to go right down to example 2. All right, please follow my lead on how to write these out. You guys will get pretty comfortable with these, and you'll stop showing your work, and then you start missing them, because if you miss one tiny thing, then you'll miss the whole thing. So I'm going to run through an example, and then we're going to try one on our own. All right, when you guys see a prism is an object that's three-dimensional, and it has bases that match. Now, sometimes your prism is rectangular like a Kleenex box, and that means you can use any bases you want, because everybody has somebody that's parallel and congruent across from it. So when you have a rectangular prism, you can choose the top and bottom as the base, or the left and the right, or the front and the back. Now most kids are like, duh, let's just use the top and the bottom as the base because it sits on its base normally. And I agree with that. So what you want to do is you want to start by writing out the formula from the formula sheet. So you go to your Prism formula, and it says Prism surface area is pH plus 2b. And so they wrote pH plus 2b. And then they went and they found all of these variables. Now what I want you to think about doing is I want you to list your variables out to the side of the problem. These are the things we're looking for, kind of like what we did when we did 1/2 AP. Okay, the P stands for perimeter, so we're going to do the P of the base every time. So the perimeter of the base is what you get when you add up all 4 sides of your rectangle. All right, so if I do my 2 plus 9, I'm going to do 4 plus 9 plus 9. So that's 9 plus 9 is 18, plus 4 is 8 more. 18 plus 8 is 26. So the perimeter of this guy is going to be 26. Now, the height of the object is the height of the object when it's sitting on its base. So when you guys see H, the H is how tall the object is when it's sitting on its base. That should be 6. And then the area of the base is going to be what we did last chapter because it's a polygon. This is a rectangle, so it's going to be 9 times 4, and it's going to be 36. And then you will take those numbers and you'll just plug them into the formula and multiply and add everything together. All right? So now we're going to try one on our own. This one's a little more complicated. So go down to this triangular prism. This is a rectangular prism. This is a triangular prism. Number one thing that you've got to do is figure out who the base is. So the bases are always parallel and congruent, and they're across from each other, and they're usually not rectangles unless it looks like the one at the top. Okay, go ahead and shade in who you think the bases are. There should be 2 of them, and they are parallel and congruent. So you should be shading in the triangles. The triangles are the bases. Now, it's not sitting on its base, so you have to really keep that in mind when you go to do the variables. Okay, so let's write the formula. So you take your formula sheet. You're going to go to the formula for a prism surface area, pH plus 2b. Okay, so write your formula. Surface area equals pH plus 2b. Now, we're going to list all the variables out to the side, P, H, and B. And I want you to do this because if you do this, you probably will not miss the problem. Okay, P, what does P stand for? P is the perimeter of the base. So I'm going to go ahead and draw this base out separately so you can see it. It is a 12 by 12, and we don't know what this side is. Okay, so in order to find the perimeter of the base, we're going to need to do Pythagorean theorem. And so to do Pythagorean theorem, we're going to set up 12 squared plus 12 squared equals c squared. And that's going to give us this side right here so that we can actually get the perimeter of the base. All right, so if you do that Pythagorean theorem and you solve, you're going to get about 17 when you round to the nearest tenth. It actually rounds to 17. All right, so in order to get the perimeter, we're going to add up 12 plus 12 plus 17, and that is going to be the perimeter of our triangular base. So that is going to be 41. All right, H. What does H stand for? The height of the object when it's sitting on its base. Okay, so if you flip this pyramid or this prism over and sit it on its base, write down how tall you think that prism would stand. Now it's kind of awkward because it's not laying on its base. It's kind of like you'd be laying down. So the height of the object would actually be 8, because if you stood it up on its triangular base, it would stand 8 tall. So even though 8 doesn't look like it's the height, it actually is. Capital B, what's capital B? That's the area of the base. So everything we're doing is with the base. So to find the area of the base, we come over here to our base, and we do the formula for area of a triangle. 1/2 base times height. So we're going to do 1/2 12 times 12. And we're going to type that in to get the area of the base. That is 72. Once you have those 3 variables, we bring them back over and we put them into the formula. And again, you'll want to do this each time so you don't make any silly mistake as you go. So surface area equals the perimeter of the base was 41, the height of the object was 8, and we have 2 bases that we're adding the areas to because we have 2 base areas. Now, once you get here, then it's easy street. You can just type all that in at once, and we'll have our surface area, which is 472 millimeters squared. Now, when you were in elementary or middle school, you would add up all the faces and do them all separately. You can still do that, but this is the way that we use the formula. It's just a little more advanced to be able to take the formula, find the information, and plug it in. Okay? All right, so now you're going to flip your page over, and we're going to look at the surface area for cylinders. So a cylinder has a surface area that's much easier to use because if you notice, the bases never change. So if I go back here, the base of a prism can be a rectangle, it could be a triangle, it could be a trapezoid, it could be a polygon, a regular polygon. So now this is much easier because in a cylinder the bases are always circles. And again, this would be the axis, just to point out a vocab word. All right, so I'm going to show you the formula for a cylinder surface area, and it's on your sheet. It is 2 pi RH plus 2 pi r squared. So we're going to write that out. And I'm just going to go into an example right here to show you. So surface area equals 2 pi RH plus 2 pi r squared. Now, for this one, all we need to find is the r and the h, which makes it pretty easy to use. So the radius is half the diameter, that's 3. And the height of the object, it tells you, is 4.8. No tricks there. It's just going to always be a circle. So now we just take those numbers and we put them in. 2 pi, the radius is 3, the height is 4.8, plus 2 pi, the radius is 3 squared. And again, we're adding 2 pi r squared because there are two bases. So at the end, that's why there's always two bases, because you have two bases in a prism. All right, so you're going to type this in. Now, I want you to practice doing this in exact form. I want you to type in everything but the pi's. So I want you to try to type in, but don't type in the pi. So you're going to type in 2 times 3 times 4.8. And we're just going to leave pi behind it. So 28.8 pi. That would be the lateral area without the bases. And then this, you might be able to tell that you get 9 times 2, that's 18 pi. Now, that's the lateral area, and we add on the area of the bases. So 28.8 plus 18 is going to give us a 46.8 pi. So we're going to leave it like that. And when you guys go to type that in on your Canvas quiz, you'll type it in that way too. And then this is centimeters squared. If you happen to multiply pi out, you would get about 147, but I'd rather you leave it in exact form for that. Okay, so that's the first part. Those are prisms and cylinders. So now what I want you to do is flip over to page 100. And we're going to look at two other shapes, the surface areas of pyramids and cones. Pyramids and cones are very similar, but you might notice that they come to a point. I want to point out one vocab word in here, and that is going to be on regular pyramids. So a regular pyramid has a regular polygon as a base, and it has an altitude that has an endpoint at the center of the base. Okay, and then down here I'm going to say the height of each lateral face is called the slant height. And we're going to use a lowercase cursive L for that. So those are the two things I want to show you. So go over to this picture where it says regular pyramid. Let me point out a couple things. If it's a regular pyramid, then the base is going to be equilateral and equiangular automatically. So every one I give you that's regular will have equilateral sides on it. The other thing I want to point out is there is a height of your pyramid, but there is also something called a slant height. And the slant height, you can see, is longer than the height. It's the height of one of the faces. So go ahead and put a lowercase cursive L there. That is the letter, I have no idea why, but that is the letter they use for slant height. It's a cursive lowercase L, and it is the height of one of the faces or the triangles. Okay, so let's go over and look at the way a couple pyramids would work. So go over to page 101, and let me show you an example of this pyramid, and then we'll try one of our own. So it says in this pyramid, we're going to find the surface area. Okay, so we take our green sheet and we go look at our pyramid formula. Okay, surface area of a pyramid, 1/2 PL plus B. Remember the L is slant height. So I'm going to write out the formula. Surface area equals 1/2 PL plus B. So go ahead and put that on your paper. And then I want you to list the 3 variables that we have. We got to find P, L, and B. Okay, so you have to ask yourself, what does P stand for? P is always the perimeter of the base. Now the cool thing about a pyramid is the base is really obvious. It's the only one, and it's usually the bottom, but it's a polygon. So we need to find the perimeter of that. So kids will say, well, what is it? Well, it's regular. These are going to be regular. So this is 12 plus 12 plus 12 plus 12. So you're going to use 48 for the base. That's the perimeter of the base. All right, the slant height. So you got to look at the picture. So the slant height they found by using this triangle. You're going to be doing Pythagorean theorem with that occasionally. If you notice, you have a triangle there. This piece would be half of the 12 down here. So that's 6. The height they told you is 16, and then this is the slant height. So I want you just to be aware that you occasionally will have to do Pythagorean theorem, and when you do that, you get a slant height of 17.1. So that would be 6 squared plus 16 squared equals slant height squared. Okay, capital B. What's capital B stand for? The area of the base. So that would be a square. It would be a 12 by 12. So you go 12 times 12, you get 144. Then you would take these 3 and you would just plug them into this formula. All right? So I'm going to actually have you go down and we're going to try one totally on our own. That's very similar to that example. Let's go down to this one. And this is a pyramid. So again, take your formula sheet and write down 1/2 PL plus B. So surface area equals 1/2 PL plus B. And then let's list PLB. And now we're going to find our letters and then plug them in. Okay, remember that this is a pyramid and the bases of these will be regular. So we need to find the base by doing Pythagorean theorem to get this bottom part. Okay, so I'm going to draw the triangle out separately for you to show you. So the 9 is the height, the 11 is the slant height, and we need to find this little piece down here, which is half the base. All right, so we're going to be doing Pythagorean theorem. So think about this as 9 squared plus x squared equals 11 squared. All right, so I'm going to solve that for you so that you can get an idea. That is going to be, I believe, 6.3. 6.3 for that. Okay, now 6.3 is not the whole side. If you look, the whole side would be twice as long, kind of like when we did 1/2 AP. So this will be 12.6 for the whole side. You'll have to double that to get the entire side of the square. Okay, so now let's go get our variables. The perimeter is 12.6 times 4. We got to go all the way around the square, and that's 50.4. The slant height they gave us, remember that's the slanted height of one of the faces of the pyramid, so that's 11. And now I need the area of the base. Well, the base is a square, so it's going to be a 12.6 times 12.6, because the area of a square is base times height, and that's going to give us 158.8. Now, all you're going to do is take those numbers and we're going to go into the formula. Surface area equals 1/2 the perimeter times the slant height plus the area of one base, because a pyramid only has one base, not two. So for this, you'll be able to type all that in. That's actually the easiest part of the problem. And you'll get about 436 inches squared for that. So just watch, because a lot of times you have to do Pythagorean theorem to help you get your height or your slant height. Okay. So let's look at, let me just pick a couple of these here. Let's look at this one. I'm going to skip around so that it doesn't get super long here. All right, let's go to this example at the top. We are going to find the surface area of this pyramid. So if this pyramid has a base that is a hexagon, we're going to be using the same formula. Surface area equals 1/2 PL plus B. And then I want you to list your P, L, and B. All right, keep in mind the base is always regular. So this will be a regular hexagon. So let's see if we know our perimeter. Well, go to the top. See how each piece is 5 and it's a hexagon? So the perimeter of the base is going to be 5 times 6, which is 30. That's easy to find. Okay, do I know the slant height? Well, let's go to the picture. Yes, I do. See how the slant height is the height of one of the faces? It is 8. So that's good. We got that. The hardest part of the problem is finding the area of the base. So what you're going to do is you're going to do what they did here. You're going to draw out a hexagon, and you're going to be finding the area of the base, which is going to be 1/2 AP. So keep in mind we just did the last chapter, and you're going to use the hexagon to find the apothem and the perimeter. All right, so to find the apothem, what I did is I drew out a 30, 60, 90 from the bottom, like we did last chapter, and I split the 5 into 2.5 and 2.5, and then I'm going to put an X on the apothem. All right, keep in mind the short side is 2.5, so my apothem would be 2.5 radical 3. So now I'm ready to find the area of the base. So I go down and I do 1/2, I do 2.5 radical 3, and then I do the perimeter of the base. Oh yeah, I already found that. That's the same as the perimeter from before, which is 30. Okay, so I'm going to multiply all this together, but I'm going to leave the radical 3 alone. So I'm going to do 0.5 times 2.5 times 30. And I'm going to get 37.5 radical 3. That is the area of the base. Now I'm ready to plug everything into the formula. So you can see how this gets pretty complicated because you have a lot of stuff going on here. So the surface area would be 1/2 the perimeter, which is 30, times the slant height, which is 8, plus 37.5 radical 3, which was our area of our base. So all I'm going to do is I'm just going to multiply this out, but I'm going to leave the 37.5 radical 3 by itself. So that's going to be 15 times 8, if I take half of 30. So my final answer will be 120 plus 37.5 radical 3. And I would leave it like that because that's considered exact form without having to multiply out the radical. Okay, so let's do one more example of a cone, and then we'll do spheres separately. Okay, so if you guys will look at the last one, it is a cone, and in a cone is actually pretty easy to do. I'm going to give you the formula for a cone, which is pi RL plus pi r squared. Okay, so let's write that down. We're going to go, this is on page 103, pi RL plus pi r squared. Okay, so we're going to put everything in that we need. We need our r and our l. Well, our r is 6, but our l we don't know. So I want to point out in this problem that you could do Pythagorean theorem to get it. So you would do 7 squared plus 6 squared equals l squared. All right, when you do that, you're going to get a slant height of, I find it, 9.2, and then you'll be ready to plug in your numbers. So it'll be pi 6 9.2 plus pi 6 squared. All right, so again, we're going to leave the pi's in there. So you're going to just do 6 times 9.2, which is 55.2 pi. And then this is 36 pi. And you'll add those two together, but leave the pi in there. So just make it 91.2 pi. Now, when we do surface area, that's going to be inches squared. That's an example of a cone. All right, so in the next video, we'll be doing surface area of spheres. I'll show you those in just a second, and then we'll go back and do volume the next round.